God. No one's working today.
Okay. Word problems. Smallville had a population of 13,000 in the year 2000, and then it grew to 19,000 by 2014. Here's the formula for population growth. So this would be a formula that it would be in the problem, okay? So P is the total population, P0 is the initial population, times E, E, which is the button in your calculator. Do you remember the number-ish that it was? 2.7-ish? 2.718, yeah. And R says it's the growth rate, and T is the time. Okay, so here we go. P is 19,000. Population. Initial population, 13,000. Times E to the R I don't know. That's what I'm trying to solve for R. And the time, how many years has passed by? 14.
You can just keep it in years, the time?
Yeah, 14 years. Yeah, it should have said in years or something there, I guess. Okay, here's the first thing I'm going to do. I'm going
He
to
actually is.
divide by 13,000.
No, but he's okay, I guess.
Okay, I'm guessing this number is not a very nice number. So I'm going to leave it as a 19 over 13, if that's okay.
He's trying, but he's like still good. If he just
Equals E to the 14R. Okay,
I know,
would we all agree right now? This is an exponential equation. Do you see your base, which is what? E to the exponent, 14R equals the result, this number, right? What do? We have to solve for this R, and you can't solve for variables in the exponent position. So what is the strategy when you have exponential? You
turn to a log.
log both sides. Okay, but wait. What can I do as a shortcut because there's an E involved? Instead of logging both sides, I'm going to
Divide by 10. E both sides.
natural log both sides. I'm going to natural log both sides.
Don't or you do? Okay. I never knew that log is a way to figure out the value of an exponent.
Okay.
Can you just do a lowercase L? That's fine.
Yeah.
Or an N? Okay.
I just did that because you guys are getting confused with I's and N's.
Yeah, I'm just wondering. It's okay.
Okay, now rules. We can split this apart, or in our calculator we can still leave it. So I don't care. You can just leave it. The ln of brackets 19 over 13 would equal the same as the ln of 19 minus the ln of 13. Do you see where I get that from? Division, split. It doesn't matter. If you do it in your calculator like this, it's fine, but it would have to have brackets on it. So you can write that, keep that, or you can write that. I'm probably in my calculator just going to leave it because it doesn't matter at that point. And what's the rule? Remember the rules. The exponent can become the coefficient. Okay, why did I specifically pick to natural log instead of log both sides? Because this ends up being 1. The ln of E is 1 because the ln uses a base of what? E, and the result was E, so what's the value of the exponent? 1. If you didn't ln both sides, you will get there if you log both sides, but then you can't just get rid of that. It's fine though. Now what? I'm going to divide by 14. So R equals, and now here's my calculator type. Okay? See if we can get there. So you can see me doing my brackets, ln of 19 over 13, that's in brackets. Divide by 14. Okay, do not take that out of your calculator, by the way, because we need it. So don't put it out, take it out. Three decimal answer when you write it on paper, but don't take it out. Does it make sense that a population could grow by 2.7%? Does that seem reasonable as an answer? Yeah. Okay. Now, I need it still. Do not erase it out of your calculator. It's still there. Part B. What is the population in 2020? So the population equals 13,000 is how we started, times e to the r, which we now know, 0.027 ... times how many years? So remember, 20 years. Because 13,000 was the population in 2000. And now I'm at 2020. Okay, here we go. This is in my calculator. Order of operations, what I'm going to do. I'm going to do that in my calculator, and I'm going to times it by 20. Right? We're good? We times it by 20. Now I need to do e to that number in my calculator, right? E to this answer. E to that answer, which I had. Then, BEDMAS, now I'm going to times it by the 13,000. Times by 13,000. And this is people, so this is something you can actually go to just a whole number. So on my calculator, it's here. I think on yours, isn't it like where your ln is? And then the opposite, like shift ln? Did it come up?
I told you.
A calculator helps when it has the buttons not rubbed off, right? Aren't yours all rubbed off? Okay, how did we do on the typing part of that?
Good.
You cannot round that and carry forward because you will get it wrong. Okay, second type of word problem. You have a money problem.
I would actually struggle for the next 3 weeks.
You deposit $500 a month. Your account has an annual interest rate of 8%, compounded monthly. How long will it take you until you become a millionaire? So you're putting $500 into your account every month, over and over again. Okay, here's what I need you to do. 8%. How do you do 8% in math? But that's an annual interest rate, but we compound it monthly. So I'm going to take that rate and divide it by 12 because it's compounding monthly. So this is what I'm going to be using to represent my rate.
So just keep it as that so we have an accurate thing? Or
Yeah,
do you
so
want-
it'll be in like that. Okay, here we go. FVA is your future value. What do we want to have in the future?
$1 million.
$1 million. PMT is your payments for each period. So how much money are we putting in each time? 500.
If you actually think about it, it's all.
1 plus
It's all what?
$1 million.
the interest rate.
Dollar with a lot of zeros.
What? Well, yeah, but.
If you were to get rich, you have to say that. A lot of people have.
So I know it looks complex, but I just substituted in, sorry, I put an R here, I should have put an I, because it's the interest rate. Interest rate in this formula.
I'm not gonna remember.
How do we get numbers from this?
Oh, no, you do not have to remember these formulas, no.
For the
So-
provincial exam, would you have to?
Nope. So yeah, when you get a question like this, these formulas, it would be exactly like this. Here's the formula, these are what they all mean, figure it out. Okay, I'm gonna do a bunch of stuff to get this alone. I need that alone. So here we go. We are going to times it by that. Good with that? Boom, that would be gone on the bottom. What else do you want to do to it?
Divide by 500.
Divide it by 500. That would be gone. And then I would need to
Add 1.
add 1, and that would be gone. And I would have to add 1 last. If you picked to do these differently, that's fine, but you would have to add 1 last. Okay, so we did got rid of, and we would have that. Okay, so you need to do all that in your calculator.
What do you get?
14.333.
Yeah, this class is actually improving my calculator work.
14.33333.
Equals 1 plus 4.
Greg's not even here to see his backwards work if you're watching this at home. Your backwards.
Got it, Greg.
You got it? With your backwards calculator?
You get that easily.
Guess where I am?
I got 134.
Uh-oh. Retype.
I already did.
You for sure did it with the +1. Did you go enter? Enter every time, maybe?
1,000,000.
'Cause I know this sounds familiar from doing it last semester.
I did. I just did.
Whoa.
I still get it every time.
Really? Okay, I'm coming over to see why. Okay, do you see where we're at now? We have a what kind of equation right now?
Exponential.
Exponential. Do you see your components? Base, exponent equals result. So what do you do to solve exponential equations?
Differential logarithm.
You log both sides. Okay, rules. Is there any rules that you see we could apply? The exponent rule. So the exponent can now become the coefficient.
She's picking West Coast.
What?
She's picking West Coast.
Yeah, she was telling me.
Okay, this is the only way to solve for variables that are in the exponent position because you can't nth root something or whatever, right? So you can bring it down.
When Reese was on her little walk with your backpack, you go out practice. You're training.
Okay, do you know what I did? I left this in my calculator. It never moved.
Oh my goodness.
It's happening.
No, but isn't it? Oh. This is -1.
Okay, so I'm gonna actually go log of my answer because it's still,
No, you're not.
log of my answer divided by log of brackets. This has to go in brackets like I have. Have to have your brackets on that. Some of you have brackety brackets.
Shift log bracket 1.
Some of you that have bracket calculators, you're going to have an extra bracket maybe on sometimes.
Equals 511.
Oh,
Oh, nope.
I did not. You got that one? You got a negative? I don't think we're going to make negative payments and get to $1 million. No.
Like LeBron.
Yeah.
All right. Carter, you're from my applied. Do you remember our financing unit?
Yeah, he does.
27.
He was
27?
telling me about that
What?
like 3 days ago.
We did this on our app, remember? What does this mean? This is your bank payments. So you're getting quizzed here. How many payments do you actually have to make to the bank?
500.
No.
Out of 1.
401.
Yes.
Yes, I knew. Yeah, we both.
Gotta be.
We both.
Okay.
So the
No
end is 401.
matter what. If this was 400.1,
Right.
if this was 400.1 or 400.2, you would still have to make a 401st payment to the bank.
Even if it's 400.0001,
You still have to make before.
technically just like
Your last payment's not going to be $500, but you're going to make. I think there's one trick question that says how many full payments are you going to make? That answer would be 400. You would make 400 full payments plus one payment that's not $500,
you
but
make 71.8% of the 500 for your next payment.
right, something like a partial. Yeah. Exactly. Okay, does that make sense at a bank? Some of you that have taken essentials maybe with your compounding interest stuff, banking stuff. Okay, 2 more types. How much more intense is an earthquake in Japan that measures 8.8 on a Richter scale compared to
That was
an earthquake in Vancouver at 5.3?
You got Curtis on. He was
not
here.
really card.
Isn't each level like 100 times stronger? Each decimal is 10 times.
I don't know. Okay, magnitude. Okay, so the magnitude on the scale. So we have
Probably.
I'm in that mood.
8.8 is the magnitude on the scale
I got basketball.
One's turning on.
equals log
When? Wicked.
intensity of the Japan earthquake divided by the standard.
But you work.
Okay, Vancouver, the intensity is 5.3
Trade.
log of the intensity of Vancouver's over the standard. So your variables here are intensity of the earthquake. S is just the standard earthquake, which I don't know. Intensity of the Vancouver over the standard. Okay, what format is this in?
Logarithmic.
Logarithmic. What are you going to do if you're in log?
Change it to standard.
Change it to
Exponential.
Yeah,
exponential.
not standard. That's what I missed.
Okay,
You said that.
ready?
Standard is general form.
Oh, yeah.
In this, what's my baby base here? What's the little baby base number? 10. 10 to the, what part is the exponent? 8.8
Corner, yeah.
equals the result.
I'll get it written up, or not written up, like, insurance.
Same thing on the other side. 10 to the 5.3 equals result.
Rooted and was staked in with a foot and a half pegs. And the wind blew it over.
That's crazy, man.
Yeah. I parked like 20 feet from where the best one that was, so even if it fell, it would have had to like slid and bolt and like, or like that.
You know, Kia things.
Okay?
Yeah, I know. You were gonna say something, so I didn't want to.
So here's where I'm going. How much more intense is this one than that one? So I need intensity. So the intensity is on this one, 10 to the 8.8 times more than the standard. And this intensity is 10 to the 5.3 times more than the standard. So how much more intense is Japan's than this? What math operation do you do to see how much more intense or more grade or something is? Add, subtract, multiply, or divide.
Minus.
Track.
Yeah, subtract.
How much more times greater is it?
It is.
Divide.
Oh, it's fine.
What?
She said time. Fucking-
How much more times greater is it? You would divide them. Okay, are you okay if I basically, I'm crossing those out, right?
Yes, ma'am.
I think it's not. Kiwi, how dirty is it? We say it's like that.
It's pretty dirty.
3 decimal places.
Okay.
Like 8 hours of it.
You don't even like it.
No, the thing is, I always fall if I have it like 8 hours. I'll find something.
8 hours. Okay.
Because it'll do it. Usually see like, I see 14 hours.
Okay,
I won't
good.
forget what it is, your card.
Calculator.
My card, your card.
Last question.
If you want, you have to
Mark on my card, but you-
How much more acidic, so I'm already seeing that I'm going to do the same thing at the end. I'm going to divide two things.
Now we gotta actually do this.
Is a solution of a pH 3.4 compared with one of 7.8? Okay, so 3.4,
Okay, Reese.
You're a bit behind in my conversation. Sorry, guys.
Yeah, we said this.
No, that's fine. I like
fine,
that
West
input.
Coast.
It was good. Can't be shooting her down like that and then expect her to keep saying those things, so we gotta encourage her a little bit. So she
okay?
doesn't completely forget about it.
So I filled into the formula.
True.
Okay, I'm going to divide by -1. I'm going to divide by -1.
Oh, heck, I'm gonna pick classes soon.
Yeah?
Yeah.
Did I pick classes together?
It's exactly the plan.
You actually should. She'd like that.
Just one class.
Yeah.
Okay,
Like,
what format did we end up in?
Because I can imagine like with
Log form. So what do you think my goal is going to be? Change to exponential. What is the base exponent equals result? Figure out all your components. What's the base on this?
the base is 1,
The base down here is
10.
10 to the exponent, -3.4, equals the concentration of the hydrogen ions.
Okay, first you were good, Cam.
Yeah, why would you teach?
Weird.
Oh, yeah.
This one
Okay.
It's just acids and bases that was
How much more acidic is the one than the other? So we're going to divide. We're going to divide. Which one is bigger as a number? Is this number bigger than this one, or this one's bigger than that one? This one is bigger. This one is bigger than that. If you accidentally did it in the wrong order, you would probably see when you get your answer as a really small decimal.
Hunter's also true for Miami.
Hunter?
Yep.
Oh. Kid fell off.
Really true for Miami.
I forgot.
3 decimal places.
Okay,